Okay, so we have here the colonial morphology identification. So, very important that we need to take note of the morphology of your bacteria under the culture media because number one, it provides us with the presumptive identification of your organisms. Second one also provides us with it also try to enhance here the quality of patient care by rapid releasing of the results on only although that one is still hindi pa siya ganun ka-final ang result natin, but then again provides here the the idea here of what might be isolated from your clinical specimen because of the morphology under your culture media. And the third one, morphology evaluation also provides us then to correlate our results, especially if we are using here the automated instrument. So automated way of culturing the bacteria. So by having that culture media or morphology evaluation, you would try to correlate na, ito sa staff, kasi meron siyang pinpoint na colony. So ito siya, may characteristic na hazy colony, so swarming motility. So that's your proteus. So okay, tama ang result ng ating automated instrument. So that we're able to correlate. Okay, we have here the different morphology as with our colony that we also need to take note. The first one, we have here the size. Okay, for the size, we could classify our morphology or colony here as okay, small, medium, or large. Okay, in the case of your gram-positive bacteria, it would produce here a much bigger in a colony size compared to your gram-negative, okay, gram-negative na mga bacteria. Your staph would have here bigger in a colony compared with your strep. Another one, we have here the form of the margin. The form of the margin is being observed here by observation here of the edge of the colony. So, itong colony natin, for example ito, so iganon mo siya. Okay, that would allow you then to identify the edge. And that become here the form or the margin. Based on that, okay, we could have here different margin na reporting. You could have your filamentous, you could have your rough, you could have your smooth. Okay, so in the case of your Bacillus anthracis, this one produces here filamentous na margin of the colony. So para siya maganon-ganon. Okay, that would eventually gives you here, okay, tinatawag siya na medusa head because of that characteristics. Another one, we have your diphtheroid produces here rough edge na colony. And we have your proteus. The proteus here would have the swarming motility characterized by haze. Nagsaswarm sila, so parang may haze from the area where you try to inoculate. Like for example, kung dito mo siya, ang colony niya, dito siya, tapos parang dito na side para siya may haze. Okay, that's swarming motility. That would identify your proteus. Okay, the next one, we have here the elevation. So you could have your flat na colony, concave, or you could also have your convex. So other name of the concave is pa ganun, di ba? Ganun. Okay, that would identify your organism here having the depression. Okay, that's your concave. Okay, so other name for that, we have your umbilicate. Okay, convex, on the other hand, siya pa ganun siya. Okay, so that's would have your bulging center, called it once your ambonate. Okay, your strep pneumoniae would have characteristic na concave. Your staph aureus would have a convex. And mga beta hemolytic strep natin would have here the flat na colonies. Okay, density or the cloudiness, tama ba? Or the thickness. Okay, so this one would be identified here by using your trans-illuminator light. Okay, so reporting could be transparent. Pag transparent is clear. Translucent, medyo hazy siya, and that would allow here the light to pass through pa din. Pag opaque, so medyo hindi na siya turbid, something like that, it will not allow your light to pass through. Okay, your beta hemolytic strep, except your strep agalactiae, would have here na translucent, okay, na density. Your strep agalactiae would have your semi-opaque. In the case of your staph, gram-positive organism here would have an opaque na colony. So we have here the Bordetella pertussis. Again, this is the causative agent of your wolfing cough. It will have your characteristic na mercury droplets. So parang siyang pearl, half pearl, or mercury droplets. Parang siyang shiny, ganon. So that's your mercury droplets na characteristic niya related to your Bordetella pertussis. Okay, another colony characteristic here, we have the color. Okay, for the color, we have here coagulates, negative staph would have your white in color. We have also here your enterococcus would have a gray. And we have also here the micrococcus and Neisseria would have here the off-white to yellow na color. For the consistency, so it's being observed here by picking your colony. So if this one is your colony, ikanan mo siya ng needle mo. Okay, so mababasag ba siya, brittle ba siya, something like that. Okay, for the staph, would have your creamy na consistency. Neisseria would have a sticky. Endocardia would have your breadcrumbs. Brittle, crumbly, breadcrumbs, wrinkled. So, para siyang amag. Okay, for the pigment, so some of your bacteria produces here characteristic pigment. The first one, we have here Pseudomonas aeruginosa produces here blue-green na pigment. So that's your pyocyanin, pyoverdine. Serratia marcescens produces here brick red na pigment. That's your prodigiosin. And we have your Chromobacterium violation. So it would have your violet na color ng pigment through your violacin. Okay, violation. Violacin, violet na color na pigment. Okay, then we have here the characteristic odor. So your staph aureus would have here characteristic na old sac. Pseudomonas aeruginosa would have here na fruity or grape-like the odor. Proteus mirabilis would putrid. Haemophilus would have here mousy. And we have Nocardia would have here freshly plowed field. So, palayan, something gana. Okay, then we have here the gram stain subculture. So, when you're picking your colony for the subculture, sinabing subculture, you try to transfer, okay, to another culture media. That would allow you to grow your bacteria. Like if you are growing your bacteria, so you need to subculture every 48 hours, 2 days. So para hindi siya mapatay, i-transfer mo siya ulit sa kanyang selective media. That's your subculturing. So from the original na culture media, so you need to pick here your, okay, ito yung mga pure colony natin. So when you are doing here your quadrant streaking, so itong area na to, you have here an overgrowth of your bacteria, then ganyan. And notice here sa last na quadrant, most likely makikita ka na ng mga isolated na colonies. So the isolated colony that's going to pick in order for you to perform your gram stain and even your subculture because this one is more of the pure culture. So kung minsan kasi may mga contaminants, but of course here the real na organism here, bacteria, would most likely grow here in isolated colony. So therefore, that become your pure culture. Try to pick that one when you're doing your gram stain. Paglagay ka sa smear, so ito, kukuha ka dito, yun nalagay mo sa smear. Or ito ang i-grow mo sa next or another culture media for the subculture. Okay, then we have here the identification of your microorganism could be in the form of your genotypic typing. So genotypic typing could be done here by your molecular testing, like for example your PCR. We could also identify our organism based on their phenotypic phenotypes like your colonial morphology, gram stain result, or even their biochemical reactions. Okay, then we have here the susceptibility to your different antibiotics, which are the basis for your antimicrobial susceptibility testing. So again, your dyes, gentian, okay, gentian violet, biosos, crystal violet, and many dyes are inhibitory to your gram positive. Mean to say, if you are trying to incorporate your dye, your gram positive will not grow. Then we have your phenylethyl alcohol, your colistin, nalidixic acid, will be allowing the growth only of your gram-positive but not your gram-negative. Then we have also here some antibiotics for your antimicrobial susceptibility testing. Okay, then we have here the nutritional requirements. So you can test for the nutritional requirements like their enzymes or even their metabolic pathways, which serve here the basis for your biochemical reactions. So you can have here the enzyme test. Your bacteria contains the enzyme. Okay, the catalase test would detect the presence of the enzyme catalase. So if your enzyme, or I mean, if your bacteria contains the enzyme catalase, it will give a positive result for this test. We have also here the indole na test is for identification of your tryptophanase na enzyme. Oxidase test is for identification of your oxidase na enzyme. Hydrolysis test is for identification of your hippuric, hippuricase. And then we have also here other biochemical reaction also try to detect here your metabolic pathways. Okay, thank you.